Yeah, we will start from linked lists. We'll go through the details. Any doubts you have from the last lecture, I will help clarify them. And yeah, maybe. See, initially, the way when we were working with, let's say, it's collection of student records. So we started with something like this, right? Car names 100. So, and then we have our function main here and some other functions. So some hash defined directives here. So where is memory allocated for on line number 3 for the variable names? Where is memory allocated? It is allocated memory in what is called as a global data. There is nothing like global stack. No, there is no global stack. There is what is called as a global data section. In that global data section, for memory for global variables is allocated. What is the challenge here? The challenge here is if you allocate too big an array, memory goes unutilized. Like for example, if you allocate memory for 1 lakh students, but there are only 60,000 students, then memory for 40,000 students will go waste. And on the contrary, if you allocate memory for 50,000 students, then you will not be able to handle the extra 10,000 students that are there. So this is the problem in allocating memory using this approach. So are you with me on this problem, the first problem, that either we over allocate or under allocate? Over allocation leads to wastage of memory. Under allocation, we will have a problem. The problem is you cannot handle extra records. Okay, so approach one. Approach one. Approach one, static memory allocation. Problems, two problems. Overestimate, underestimate. Memory is allocated in global data section. Global data section. So overestimate, memory wastage. Underestimate, can't handle the complete data, the complete whole data. So these are the two. And what is approach 2? Approach 2 we have seen. Approach 2 is where we allocate memory on the heap, dynamic memory allocation. Dynamic memory allocation. We allocate memory on the heap. We start with an initial estimate, and we keep, whenever our estimate goes wrong, we keep making a sequence of real-log calls. But these are very expensive. Real-log calls are very expensive. So this is the current story. Are you all with me here? And one important thing is in both these cases, the whole data is present, all the records are present linearly, linear memory layout. Linear in both approaches, linear memory layout. Linear memory layout, this is the story in both approaches. That is, all the records are laid out one after another in the memory. So we are not happy with this because while this is a very good thing, very nice, linear memory layout is very good. But the other problems, no, they are hard problems. They are, so we want to come up with an alternate approach. In the alternate approach, what we do is we take in the memory heap, we call it as a heap. And so we have a student record. We read a record, we allocate memory. This is all heap memory. And when you read a next, when you get one more, when you read one more record, you allocate memory for that one more record, and you create a pointer to the new record from the old record. And if you have one more record, then then again you will repeat the same process. So your data is stored as a collection of records, and each record gives a pointer to the next record. The address, it holds the address of the next record in the memory, so on and so forth. The line within the box, this is the data and this is the pointer. There is a data part and there is a link part. So that line indicates, this can be your name, marks. Oh, I'm not recording. Yeah. I'm recording, right? Yeah. So this is data and the other part is the pointer. Okay. So similarly like this. So the advantage with this is you are allocating every record on a demand basis. Only when there is necessity for memory for one more record, you allocate memory. But this is a nonlinear data structure. This is the data is spread all around. Nonlinear or irregular data structure. Irregular data structure. Your data is present. No, it's just that when you keep making, in order to get this, you make one malloc call. And then for every time you need a record, you make one malloc call. So these records, they are not adjacent in the memory. But whereas if the data is in an array form, the record 1 is present here, record 2 is R0 here, R1 here, R2 here, it's all linear. But here, it's all over the place in the memory. Okay. Are you all with me here? So this is array, linear data structure, regular data structure. This is a linked list. It's an irregular data structure, nonlinear data structure. And every time we want to allocate memory for a new record, we make a call to malloc, and somewhere in the heap where there is free space available, malloc gives memory for it. Okay. So now, so in the particular way we are doing right now, there is no mix. This is completely, we are just having a collection of records which are spread all over in the memory, and each record points to the next record in this in the heap. So this is the approach we are going to take. In approach 2, we are asking for memory for 1000 records in a single shot, Muskan. All the 1000 records are. So if you see the code, when you do an malloc, you ask for, when you do an malloc and then realloc, you ask for a big chunk of memory. You don't ask for one record of memory for one record. Good questions, Ardhak, you will see in a moment. Yeah. So now let's get going. This is not at all like realloc. No, this is not realloc, guys. So this is, so let's look at this code. In order for us to be able to so look at the code from line 7 to line 11. We are defining a new data type, and the data type is student. No, we call the data type as student underscore record. There are three fields in it. The first field is a character pointer. It points to a string, and the second field is marks, and the third field is next field. This is a pointer to another structure in the list, to the next structure in the list. Are you with me here? Line number 10. This is a pointer. Just take it as a syntax, and it is a pointer to a next structure which is of the same type. Okay. So that is the reason we are using struct SR here, and the same struct SR is being repeated here, because we are pointing to, next is not a keyword, it can be anything. It can be link or it can be anything. No, it's just a variable name. So we are pointing to, this record points to another record, and the type of that record is also the same. Just follow what my line of thinking. We will figure out the details. So there are three fields in this record. First is name, pointer to a name. Second is marks, and third is also the third field next. It's also a pointer, and it points to the semantically what we want to do is we want to hold the address of some other record in this pointer variable. So now let's see, we want to read the student database. So look at this code on line 23, and pay attention. On line 23, I did few changes for section A, so now I have. So what are we doing in line number? Look at the loop from line 21 to 22. In every iteration of the loop, we read a record, and a record consists of name and marks. And when do we stop reading? We stop reading when we hit an end of file. Simple. Are you okay with me till this point? We are trying to read the record and want to construct a data structure. In every iteration of the loop, we read a name and the associated marks of the student. So now we want to create what is the formatting symbol? Formatting shortcut is what? Control Shift F. Control Shift I. Okay. Oh, okay, I have to store this one. There is no formatter for C files installed. Anyway, leave it. Weird. Okay. So yeah, so now we want to create. Okay. So after reading, so next thing that we want to do is we want to create a record. So S record. What should we do? What is we want to do malloc? What is the pointer to malloc? What is the parameter to malloc? What is the parameter? What's the size? Size of structure. How do we specify that? No, not size of. We want to allocate memory for the whole student record. Every student, we store information in this record. Size of student underscore record. And we have to use an explicit typecasting, student underscore record star. Are you with me on line number 24? We have allocated. We have allocated memory for one student record. Now, having allocated memory for one student record, what is the next thing? So S record is a pointer. S record holds the address. And so, yeah. So let's say, where is S record located? Where is S record located? Let's say this is heap. No, S record is a local variable in the activation record. So S record is in the act. So this is your S record. Okay, this is S record. And it's in the read, exactly, read student DB activation record. So this is in the activation record, AR. And then heap. When we do an malloc, what happens is, let's say the address that you get is something 0xx A0. So this A0 is what is present in S record. So now at this address, memory for 3 fields will be present. Name and the marks. Maybe I should use next field. So A0 contains this. In order to access these fields, since S record is a pointer, since S record is a pointer, we have to use, there are 2 ways of doing it. One way of doing it is using the arrow operator, S record name. So what this does is it takes the base address, it takes the address of S record. So what this statement does is the memory to which the address will be written. So whatever the contents of S record, okay, S record plus offset of name within that structure. What is the offset of the field name within this structure? What is the offset of the field name within this structure? Offset means how far is it from the base? It is at 0 offset. Within the structure, name is at a 0 offset. Marks is at a offset of, no, not 1. Marks is at an offset of 8, size of char star, 8. Okay, and next is at an offset of 12. Great. So when we use this, so the address plus offset is added to compute the target address at which the memory update has to happen. Does it make sense? That's what this means. An alternate way to do this is star srecord dot name is also an alternate way of doing it. Okay, but let's prefer the arrow operator. So Mano, it's very simple. srecord is, what does srecord contains? srecord contains A0, that is the base address. srecord contains the base address, and the offset, in this particular case, the offset for name is 0. A0 plus whatever, this gives the address at which the update has to happen. That's all. That's what when we are working with pointers to structures, the way we have to access the field names is by using the arrow operator. Membership operator. So why is the offset 12? Because this is at an offset 0, this is at an offset 8, because the size of character pointer is 8. Marks is 4 bytes. So yeah. So overall 12. Yeah. Shall I move on? srecord is a student pointer, na? srecord is a pointer. So what should we have here? If it is srecord, if it is not a pointer, let's say there is something else called as temp record. If it is temp record, the way we access the fields is temp record.name, so on and so forth. Yeah. So what's on line number 27? Can you help me fill? What should we do on line number 27? We want to do string copy, no? We have to first do a malloc. We have to allocate memory, strlen, stringlen, temp name plus 1 char star. Okay, and after that we do string copy, srecord name, temp name. And then why are we allocating memory again? So Meghna, on line number 8, we are not allocating, we are allocating memory for an address which can hold the address of a base address of a string on line number 8. So size of a character pointer is 8 bytes independent of whether it is Meghna, Sarthak or Ashmit or whatever it is. So here is the place where we are actually allocating memory. So this is a very important question. You will definitely make mistake later if I don't tell. So that's the reason I didn't take the easy path. An alternate way of doing it is this. When we do this, then we don't need any separate memory allocation. Now we are not allocating memory for a character pointer. We are allocating memory for a sequence of 30 characters. Are you all with me? Do you see the difference between 8 and 9? Okay, so I would like to go back to this original. Yeah, but that can lead to over or underestimate. Line number 9, this can lead to over or underestimate. No. So now what is the next thing we should do? What's line 30? What should be the code? Line number 30, marks. Yeah, marks is equal to marks. So now we have created a structure. And which holds the marks and all. So now we want to do one thing. Okay, so what we want to do is head is, let's say, our list is like this. So head is a pointer, head is a variable which holds the address to the first element here, here. So when we want to add a new element, new node to this list, what we have to do is we should make this point to this, and we should make head point to this. So what we do is right now, so that means in order to, how do we do this? What is the statement for this one? Can you tell me how do we do this one? Step 1, how do we do? And step 2, what is the code for step 1? S record, next should be what? S record next is equal to head, and head is equal to S record. Are you all with me here? Ashish, you will take that. We can do that. Let's use this simple method for the time being. We are adding back from the backward. That's true. We are adding in the backward. See, when we created a new record, so we want to add in this, whatever this color. What is this color? This is green. Huh? So neon. Okay, green is a good approximation. So we are adding this green record. So, and we are adding it at the last or actually first rather. Okay. So what happens is head is pointing here, whatever head is pointing to, we are making no S record of next point to that. This is what line number 32 does. And then after that, we want to move head point to the new record that we have added. It is like students are coming and they are being added in front of the queue. Initially head is null. This is like a place where last in first out, you can call it as. Let's not use that right now for the time being, but simply speaking, whoever is coming, they are coming and standing at the beginning of the queue, head of the queue. People who are coming late, they are coming and they are being added at the head of the queue. Are you with me here? It's okay. For the time being, we can ignore stack, LIFO, all those things. But essentially, as students keep coming, you just keep adding them at the beginning, at the head of the queue. Okay. And let's say the base case, when the head is initially null, when no one is there, what happens? You have created a new record. When no one is there, this is the base case. So this is the new record that you have created. This is head. Then what happens? We say S record next is equal to null. So what happens is this becomes null. Okay. This becomes null. And we make head point to this. So even in the base case also it works. Does it make sense that why it works even in the base case also? Even in the base case also it works. So here if you look at this one points to null. So you keep going and then the last record here it points to null. Yeah. Are you all with me here? I want you to think of two cases. One is the base case, the other is the induction case. Whenever you are working on these problems, think of these two cases, base case and the induction case. In both the cases, it will work. Okay, so now what do we do? So now what we want to do is, the next thing that we want to do is, we want to print this database. So we start with the head. Okay, so we should start with the head. So let's call, we put our finger on the head to start with. Okay, we put our finger on the current node. We put our finger on the head and we check if it is null or not. Like for example, if no one is there, then current, the first time when we keep a finger, it will be null, right? So in which case, you don't need to do anything. The list is empty, you come out. Yes or no? So if no one is there in the list, you come out. But let's say on the contrary, if someone is there, what do we do? We want to print it. Printf %t/t %e. Are you with me here? That's all. And then after we process the current node, what is the next node that we should process? Let's take a different color. Yeah. So we process this one. This is the current node. After that, in order to process what will be the next node? So you have to go to the current node, next of current node. Okay. So what do we do? So we come here, we say current node is equal to current node next. And then the loop starts again. Does it make sense? The loop. After we process, then Abhinav asked some question on printing. So my knowledge on printing is also very minimal. I just try to figure out what to do based on. What happened? Why didn't? I have to call them. Print student. Okay, so you can see the names.txt file, it comes in the opposite direction. Because we are, the students who are coming late, we are putting them at the head. And because of that, they are coming in the front when we list them out. Are you all with me here? What's the good part about this? I can add many names, like I can say Aman 22. Okay, is Meghna there already? No, I guess Meghna 33. Pratham 32. Okay. So now we don't need to worry about anything. It's just I can just do anything. There is a way to, of course, there is a way to this. We are writing our program. We'll change our program so that we change the order. That's not the point. Okay. I just want to show one simple way of doing it. So one point I really would like you to appreciate here, we cannot do the print loop from the end because the pointers are the other way. Let's say if we don't do this, what happens? What do you think if we don't do line number 28? Line number 28, I just commented it. Okay. Only one character will be printed. Huh? No, because yes, the variable, this variable name, it contains some random address. You go and try to override that address when we do a string copy, and it will give to segmentation fault. Do you understand? That the record, the S name, the name variable in that record, it contains some garbage value. You try to go and update a memory location which is pointed to by garbage value, and it can lead to all sorts of problems. So now if you try to run, you'll get segmentation fault. Are you with me here? This is a very, very important point. I cannot emphasize enough this thing. And the way to find, to solve this problem very quickly is use GDB. GDB out. Okay, let's do one thing. That's what I am telling Manav. Again, why this is coming? Okay. Run. Okay. So now let's say we can see that there is a, you can see one interesting thing. This is SSC3. Okay, so I'll not say anything more about it, but I'll leave it there. But in read student DB, while doing a string copy, there is a segmentation fault. You understood why there is a segmentation fault? Because we didn't allocate memory for the name, we just allocated memory. See, when we did a malloc on line number 27, when we did an malloc on line number 27, how much memory we get here? So this is for, we just get memory for 3 fields. One is name, one is marks. So this is name, this is marks, and this is next. This will get 8 bytes, this will get 8 bytes, and this will get 4 bytes. So the size of the structure is 16 plus 4, 20. You are not allocating memory for the name. In order to get, if you are actually, let's say if you are storing Mano, you have to do allocate memory for Mano somewhere here and store this address here. Let's say the address is A0, the address of, then you put A0 here. Next is also a pointer, right? All pointers, they may take 8 bytes. Are you all with me here? Shall I go ahead or? Memory map of Tias. I didn't get it, Venkesh. You think about it, okay? I think I gave lots of different ways of explanation. Think about it, and if it's still not clear, maybe I will clarify it in one of the office hours. Okay. At least how many of you are with me? Let's see. If it's not, I'll see how bad I'm doing. Okay. Let's see. We try to rewatch and because I'm not able to see what other ways of explaining what's going on. So, because I'm just giving an extra picture of what is happening. Memory diagram is what you are seeing on the right. Okay then. So let's keep going. So this is, so now we are able to, yeah. So the first milestone is we are able to see, in order to explain what is going on here, let's say, after you leave IIIT, you all make a lot of money, you have become rich, and you bought an apartment. Okay, if someone gives you, and you go to registrar office, you get a document saying, no, this apartment is yours. So, but that's just a document, no, but you need the actual space. You need the actual apartment. It's if someone just gives you that, if someone gives you just that document, registration document, will you be able to go and live there? That document, that apartment actually suite or whatever it has to be. Registry contains the address of the house. It doesn't contain the house. You need a house to go and live. Okay, so if you don't get this, then you don't deserve an apartment. You better get it. Yeah, I'm just being too harsh. Okay, sorry. But you understand the analogy that that's what is happening on. Well, it depends on whether you get it now or not. So that's what on line number 8, you're just getting a registry document, and you have to get, actually you're just getting a paper in which you can write your the address you have to go get your apartment and get it registered, and that's what the second malloc is doing here. This is, let me do one thing. Get your apartment allocated. If you go and try to crash in some other place, you'll get into trouble. Okay. Jail. Segmentation fault there will be segmentation fault in your life. So okay. Yeah, so let's now, what's the story? Okay. Well, yeah, so now, so there is no GDP moment. Okay, so the next thing I want to show is right now we are working with the cool thing about this. What is the cool thing? I can have as many names as we can. You know, like earlier I was worried, whether if I want to add more names to this list, whether the memory is sufficient or not. All these things also we are worried, but right now with this with the particular data structure approach, we can have as many names, so we would like to have, like, for example, Abhinav is not there in our list, so we can put Abhinav in this. So as many names as we can have. So okay, so yeah, and then so we are working with what are called as dictionary data structures, where 3 operations, apartment, Abhinav, apartment, insert, delete, and search. So insert record, delete record, search records, these are all common operations we do on what are called as dictionary. What is the spelling of dictionary? Yes. I'm sorry. Okay. Sorry. Dictionary. Awesome. Dictionary. Yeah, I like Siddharth's dictionary data structure. So, all right. So now let's say we want to support a search routine here. Why 82 students only? They gave up on the class. Okay, what to do? So void search db search key and if string compare current node name search key equal to 0. Then search is successful, in which case we return current node. Say, I'm not in favor of sending code because I want you to look at the lecture, slowly type in the code. It will help your learning process. Okay. Does the search key, does this routine make sense? Yes or no? We are returning, once we find the node, we return the base address of the node address. Something happened, Abhinav, it's not working, IntelliSense. Okay. Are you with me here on the search DB code? This is very simple. We are doing a linear search. Okay, so we are traversing the linked list and trying to find. We are doing a string compare. Oh, okay. Void. It's not int. Student underscore record star. Okay. So now we are doing one thing. So while scanf percentage command search key if string compare search key just follow what the code. I'm not following the chat for a while. I'm looking at writing my code. So if it is equal to 0, then break. If it is equal to ls, print student db, continue. Otherwise, yes, record is equal to search db search key, and if record equal to null, enter percentage not found. In the database, search key, continue. Otherwise, enter. Are you with me on the code, what I am writing? What is happening? Check now. So you have written so many programs. After solving assignment 3, this should be a cakewalk for you. what are we doing? We are semicolon on line number 7. So check line number 75. Okay. What else? So here, why do we need continue on line number 76? If the key is not found, we want to, it's a kind of infinite terminal. So if key we are designing a terminal. Let's run this program and see what happens. Okay, let's run this program. GCC linked list section b.c data out. What happened? Okay. So I entered all these names. Control D. Okay. So now we read the list of databases and it is waiting for input. Whenever I press ls, it shows the list of records. Yes or no? Does it make sense? ls list of records. Where is it? Yeah, ls. Yeah. That's what we are doing here. And let's say it shows the marks. Let's say Kapil. So Kapil not found in the database. Sorry, Kapil. I should have had a slash in here. Yeah. And if I give Shivam, let's do one thing. And then if I do quit, it'll quit from the program. Let's compile this program one more time and run it because I didn't like this. Okay, so now let's see if Vrunda, what's Vrunda's marks are. Vrunda is okay, 18. Okay. So are you all with me on this code? So if we give some, there are two things. If we give ls, you have to write your own code program to find the length of the linked list. So ls gives the list of all the records, and what else? So what are the quit means? Yeah, you quit from the code, and so that's it. So you give a search key, and if it is present, let's say copy. So now let's say if you search for Brahad, it says not found in the database. Are you all with me here? This simple code, how you can write a terminal. So when there is when we see quit, we want to come out of this loop. And now we want to do one small thing. See, that is, we want to read input from the file. We didn't know. This is not nice. So what we want to do is file star fp. So fp is equal to fopen rv of 1 read and read database fp. Do you see what we are doing on line 62 and 63? Do you understand what is happening? We are opening a file in read mode. We get a file pointer, and the file pointer we are passing it to read student DB. Are you with me? 62, 63, semicolon 62, 63, okay, right? Line 62, 63. Now we go here, read student database file star FP. We do simple stuff, fscanf. That's it. Fclose, we don't need to do fclose in main because if we are just reading the file in read mode, so it's not a big deal. We don't need to give the file name. Now we have given command line argument. On line 62, we are giving the file name as a command line argument. Yeah, so there are a few things we can do. Control L, GCC linked list. Okay, database read. So you want to know who are all there in the database? What should we do? LS. Siddharth. Let's see if Siddharth is there. Sorry, Siddharth, you are not in the database. Okay, so that's all for today. We learned about linked lists. So Ashish is also missing. Let's see. Yeah, so Nipun. Fit. Okay, so that's all I have for you today. This is the code. How will we delete stuff? You figure out, Anika. That's part of the homework. Can we also edit name and marks? All those things are possible. You just have to keep writing more and more code.